AI tools like ChatGPT can transform how businesses work. You don't need me to tell you that, but there's a massive problem. If you're dealing with sensitive data like financial records, personal information, legal case files, or healthcare data, you simply cannot use public AI APIs. Sending confidential client documents to OpenAI or Claude, that's a massive compliance nightmare waiting to happen. So what's the solution? Well, you need to deploy open source AI models privately with endpoints that you can control, where your data never leaves the infrastructure and it isn't used to train future models. So in today's video, that's exactly what we're going to talk about. I'm going to walk you through how to do that. Now, a developer on Reddit actually built a private ChatGPT specifically for lawyers, and he made $35,000 selling it. Not bad. So we decided to rebuild that solution from scratch and show you exactly how you can do that, but you're on your very own GCore infrastructure. So if you're watching this video, I really think that there are two opportunities here. First, you could actually build a similar solution and you could sell it to legal firms, accounting practices, or healthcare organizations. As an AI consultant, this is kind of some of the work that I do. And secondly, if you work at a company handling sensitive data and you've been hesitant to adopt AI due to privacy concerns, you can actually learn how to build a fully private AI assistant yourself, and it's going to make your CIO or CTI and compliance officers so proud of you. So today we're going to cover how to create your own private ChatGPT using OpenAI's new open source model, running entirely on your own infrastructure with GCore's H100 GPUs, renting the hardware, setting up secure SSH access, installing Ollama for AI models and N8N for workflows, building the database with Chroma DB, and troubleshooting real-world issues. So this is all based on my actual experience building, including all the bumps along the way. So you're going to be able to learn from my mistakes and hopefully not make the same ones that I did. Now, to make this dead easy for you, along the way, you're actually going to see a virtual command terminal with all the exact code for you to simply copy. So without further ado, we're going to be covering a lot in these next 20 minutes. Let's get into it. The first thing we need to do is set up some powerful hardware for running your own large AI models. Now, GCore offers some bare metal H100 GPU, and I think these are ideal. 80 gigabytes HBM3 memory, perfect for a 120 billion parameter model like GPT OSS. So there is the option of running GCore's everywhere inference and renting some virtual machines for N8N and Chroma, but renting a H100 allows us to spin up Ollama. GPU Cloud is great for lots of use cases, and it allows us to quantize the model or take that extra bit of control over the model if we need to adjust it at some point. There's also plenty of space for running other models and other AI projects as well if you want to. So start by logging into your GCore account, sign up if you haven't already. Then you want to go to bare metal servers, create server. I chose the Senes, Portugal location, and this is great for low latency if you're based in Europe, as GCore is. It's European, which means we're fully GDPR compliant. Select the H100 config. Note virtual GPUs were actually out of stock for me, so bare metal it is. Before deploying, set up SSH keys for secure access. So you don't need passwords for these, which is crucial for compliance. And on your local machine, you want to generate keys using the following commands. Upload the public key to GCore under the SSH keys section, and you want to name it something like H100 access. Deploy the server with Ubuntu OS. This is a Linux OS. Now, I found that this was actually pre-installed on the GPU that I used. Then select your SSH key. Once deployed, note your public IP. Now, a great tip is to test the SSH immediately so you don't have any issues. If there are issues, you can check firewall or key permissions. Now, we're done with SSH keys, let's move on to case studies. Now, of course, we need to actually create some case studies to put into the Google Drive. I use Grok to create some funny made up case studies for the world of Harry Potter, as you can see. Now, I love Harry Potter, and why do we need to do this? Well, it's important that we don't use real data from the internet in case it's already in the training data for GPT OSS. But for Harry Potter geeks out there, these are kind of like fan fiction, so they're building on real characters and minor characters from the book, so do check them out. Now, the next thing we want to do is install the core tools, Ollama, N8N, and Chroma DB. Now that we're securely on the server via SSH, let's install the tools. So first, Ollama for running GPT OSS 120 billion parameter model locally. And here are the commands you need. This downloads the 65 gigabyte model. It took me about 20 minutes, so super fast. Then you want to test it. So again, here's the command you need to test it. It should respond locally, no internet after download. Now we want to set up the N8N Workflow automation. So I use Docker for isolation to set up N8N, and again, here is the code you need to run it. Then you want to access it at this address, and then you want to create an account. Finally, we need Chroma DB for the local vector store. So again, we're going to run that on Docker, and here are the commands you need to run and set that up. Then you want to test it, and it should return a timestamp when you test it. This is all local, all compliant, and no data leaves the server. Now, the next thing we want to do is we want to build the N8N workflow. Of course, this is using RAG. So RAG legal chatbot. so it's going to use N8N very heavily, and we're also going to need some embeddings in there. So what I did is I actually went out and found this template for a RAG chatbot using Google Drive, Gemini and Pinecone, but of course those tools aren't compliant, but all we've got to do is switch them out. We don't have to start from scratch. So we want to import this template, go to templates, search RAG chatbot for company documents, and then import. Big shout out here to Automate with Mark for this template that we used. For the prototype, I used N8N's internal database. It's simple for testing, but it gets wiped on restarts. So it's a great starting point to get it to work, but obviously for production, we want to switch it over to Chroma DB. Now, of course, you may also have heard of Neo4j, and it's worth pausing here to consider the differences between the two. Chroma DB and Neo4j are both fully compliant, but Neo is a lot more complex. Chroma DB queries are straightforward. You just simply provide a vector and you get a simple vectors back. Neo4j requires learning Cypher and understanding graph data modeling. For a RAG-based chatbot, Chroma DB integrates more naturally with embedding models and LLMs. Remember, Neo4j would also require additional layers to convert between graph queries and vector similarity. But if you are a massive corporation, you've got lots of different types of documents, contracts, NDAs, case studies, minuted minutes with clients, Neo4j might be an option. It's important to underscore that both Neo and Chroma can meet enterprise compliance requirements, but they do have different considerations. Chroma DB offers simple security models, and it's also primarily about document storage and retrieval. Access controls are more straightforward, and audit trails are easier to implement. Neo4j provides robust enterprise security features, including role-based access control, encryption, and detailed audit logging, but it requires more configuration to implement properly. Now, before we dive back into nodes, we need to spend a little bit of time talking about text splitting. Do you actually need a text splitter? Well, in RAG workflows, text splitters tend to chunk long documents for better embeddings. But you might want to skip this if your files are already short and they're under 1,000 to 2,000 characters, they're well-structured case studies, and their individual contracts or brief legal summaries. Now, for my setup, my documents were already short, so I don't need the text splitter, but what you can do is you can test your docs, and if embeddings work without them, then generally you don't need it. Now let's get back to nodes. Now let's have a look at these two workflows. You can see that there are actually two N8N workflows that are going to be running in parallel. One to handle adding new docs from Google Drive to the database, and the other one to handle chatting with existing docs from Google Drive. So we're obviously going to switch out the nodes that we don't need for the nodes that we do. So let's summarize the key replacements here in this workflow from the template for compliance. So we're going to move out Google Gemini Chat for Ollama chat model, and your base URL should be your server IP model, GPT OSS 120B. We're going to get rid of Google Gemini's embeddings, and we're going to instead use Ollama's embeddings. The model we're going to use here is Nomic embeddings text. So we're going to pull this with Ollama pull Nomic embedded text first, and then we're going to switch out Pinecone for Chroma DB. Now there is no official Chroma DB node, so we're going to need to make a HTTP request, and there's a post request to query the embeddings. We want to connect Google Drive as well. For queries, we're going to post the query to query embeddings, and then we're going to move on to Google Drive. We're going to want to connect our Google Drive account for document input, split the text if needed, and then embed with Ollama store in Chroma DB or an internal database, then query for AI agent responses. Now, since this is an MVP, we're actually going to start off with the internal database first. Activate the workflow, and now it's fully local and compliant. Now, the next thing we're going to want to do is create the front end in Loveable. Now this is very easy to do in a one shot, and here was my prompt. Now of course you can use this yourself, or you can use Streamlit, but for me I just think Loveable at the moment is the best tool. You can even attempt to use OSS yourself, which is already running on your server, but overall I just think Loveable is the best tool for front end dev work right now. I had to add in a settings feature for me so that I could include my web hub to connect it in the back end to my front end, but you can include that instruction in your initial prompt so you don't make the same mistake. Once you're happy with the code, save it to GitHub and you are ready to deploy. Remember, if you're going to deploy this as a web app to a domain, you must implement robust authentication. So this is great for testing, but remember you can actually use Electron to convert it to an app that runs on your system or on your server, and to be honest, this would be our recommendation long term, and you can easily do this by running a few commands in terminal. The next stage is to troubleshoot some common issues. As you probably know, setups rarely go smoothly, and you know that's completely okay. That's why I'm making this video for you. Bit of a power cut there. Clearly, too many GPUs overloading the system here where I am. So here is what I ran into, and how I actually managed to fix it. First issue, lost N8N workflows after a Docker restart. Now, unfortunately, if you restart N8N, then it wipes the database. Now, I had to do this as I was actually not running N8N on the IP address, but on a local host. The key fix here is to make sure that you extract the JSON at regular intervals from the browser console, and you ensure that you're backing this up. Alternatively, what you can do is you can simply copy and paste the N8N workflow to another N8N account, which is in fact running on the web, hosted by them, so you don't lose everything. So the lesson here is back up your workflows regularly. The second issue is that Ollama was not connecting to the N8N localhost, and it simply didn't work from Docker. The fix is to use an internal IP or host Docker terminal internal, so you can test this with curl first. Another big issue was Chroma DB's API errors. So the collections endpoint had coroutine issues. To fix this, you could use the collections ID instead of a name for call. So test heartbeat and version first. For N8N, use HTTP request for add query with embeddings from Ollama. Now, a very seemingly small issue, but one which actually got me bogged down for a few hours, was the embeddings model not being able to fetch N8N. N8N couldn't list the Ollama models. Now, the fix for this is that you need to manually type the model name. So that needs to be GPT OSS 120B or nomic embed text instead of the drop down. So you always want to test the components individually, curl for APIs, Ollama for run for models, before integrating into N8N to make sure everything works. Another issue which got me quite stuck for a few hours was the N8N server needing Google Auth. Now, of course, this is something that I knew I was going to face, but for callback with Google Auth, you may need to create a DNS redirect to ensure that you can properly connect Google to N8N. It's not simply going to go to the IP address that your server runs on. Now, GCore actually has a redirect service, provided you have a spare domain. You may also consider whether you need to use Google Drive for storage, and you may wish to use local storage for file uploads. For testing purposes, you can get around this by using a Google Service account, and that's exactly what I did. Now, before we sign off, there are a few extra things that we obviously want to ensure for security. So whether you implement all of them will really depend on the nature of your organization and what specific compliance restrictions you need to put in place. First of all, you want to use HTTPS with NGX for all services, which is very easy to do. Store all data, that's the model weights, Chroma DB, N8N logs on the encrypted volume data. You also want to implement JWT in NGX, like proxies like Chroma DB and N8N. You can simply install NGX with the following commands, and then you want to reload NGX. Access controls. So to implement JWT authentication across all services, you want to restrict access to authorized users, for example paralegals, via GCore's firewall or VPN. Audit logs. If you're a big organization, you probably want to log exactly who and what is being queried in the database, and for this we need to set up a PostgreSQL database. You might ask, quite rightly, why not use Chroma DB for audit logging? Well, Chroma DB is a vector database for embeddings, not relational data. It lacks efficient support for timestamp-based queries, actions, or user metadata, making audits cumbersome. PostgreSQL is better, relational structure, SQL queries, scalability, and compliance tools. Start by installing and running PostgreSQL, then you want to SSH either into the VM or the GPU. Run PostgreSQL in Docker with encrypted storage, then you want to create a log table. Integrate the logging with N8N, add a logging node to your N8N workflow, use N8N's PostgreSQL node if available, or HTTPS for custom inserts. Now let's see it in action. So we'll obviously upload all our case studies to the Google Drive. The N8N downloads the embeds with Ollama, installs them all in the internal storage or Chroma DB. And let's ask the chatbot what happened in the McGonagall case. And as you can see, it's retrieving the docs, generating the response with GPT OSS, and this is all locally, it's all happening on the H100. No external calls, the data stays on the server. It's perfect for open source and for legal use cases. So there you have it, a fully compliant legal chatbot on GCore's H100s with N8N. Now you can use ChatGPT trained on your company docs, resting easy that you're fully compliant and you have full control over your data. Now, obviously this is an MVP and it's a proof of concept, but you can see that it works and it's a great foundation for building this out in so many different directions. If you hit issues, check the comments or GCore docs, or drop me a comment and I'll do my best to respond. Like, subscribe, and let me know what you want to build next. Now, thanks for watching, and we're going to put some links that will hopefully help you build this in the comments below. Alright, I'll see you next time on the next video.